structural analysis 2. Let's see how we can determine a static degree of indeterminacy of a structure. So in terms of formula for static degree of indeterminacy, we have two formulas in structural analysis. One of them applies to truss and the other one to beams and frames. So let's see the easier one, which is for truss one. SI, statically indeterminate degree of a structure, is number of members plus number of reaction minus times twice of the joints which connecting the truss to each others. And for beams and frames, so like we said, M is number of members of truss, number of reactions, and number of joints. For beam and frames, equation is a more comprehensive than the truss one, and that's a 3 times member plus reaction in parentheses minus 3 times J, 3 times joint plus the uh, special condition like internal hinge and so. Let's put it in some examples. Find degrees of static indeterminacy SI for 2D structure shown. So if we want to know what is the degree of indeterminacy of such a structure, so SI is number of members. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 1, 2, 11, and let's say 12. So we have 12 members plus reaction. These are pin. Each of them has x, y, x. Like for example, if this is ax, this is ay for pin, like we do in also like b here. So there are 4 reactions times twice of number of joints. So let's have joints here: 1, 2, 4, 5, 6, 7. So if you subtract 14 minus 16 minus 14, that's a 2. So our statically indeterminate for this truss is number 2, as you can see here. So we can easily see we have 12 member reactions, 7 joints, and that's the leads turn to 2 degrees of determinacy. And let's solve a beam example. So use this equation for beam. So definitely have ax, ay, and ma here, and like here by rb. This is a roller, and this is fixed support at a. So we do simply know we have another 1 member because it's only 1 beam, and reactions are 4 at fixed and 1 at the vertical component roller. And joints, if you want to model it, just 1 joint, and the other one here is j is equal to no special condition. So you can easily see that's a 3 plus 4 minus 6 leads to 1 degree of indeterminacy. Let's review. So if this is a internal hinge, as you can see here, so use the equation for beams and frames, and you can easily see number of members are, if you call it section 1, section 2, section 3. So members are, reactions are here, 1 here, r is 5, j is equal to 1, 2, 3, 4. And special condition, there is a hinge which connects the 2 part, and it just leads to 1 special condition. So 3 times number of members plus reaction minus times joints, which is 4, plus 1 special condition is equal to 1. For special condition, we just look at the hinge. If it just connects the two part, special condition is 1. Frames, for example, if the internal hinge connects the three part, its special condition is 1 minus the connected members. So say C special condition in this condition is number value of 2. So in this case also we have a statically determinacy of 1 degree, and let's see, we have a frame example determinate. This is a fixed one, this is a fixed one. Again, writing down the equation, number of members, member 1, reactions definitely here leads up ends up to have 6 reactions. J number of joints is equal to 4. This is 1. And special condition, we don't have any internal hinge, so 0. So that's a 9 plus 6, 15 minus 12. That's a 3 degrees of statically indeterminacy. Determinate frame. And for last frame, if you have a fix at the beginning, fix at the last support, and the others are just pin. These are pin. So in such case, we do have a reaction, 3 reaction. 3 is 6 plus 2 at the center. So we have number of members 1, 2, 3, 4, 5, 6, 7. Members are 7, reaction are 10. Joints are 1, 4, 5, 6, 7, 8. And that's J special condition. So 1 plus 10, 31 minus 20. And that's simply degrees of statical indeterminacy is 7 for this indeterminate frame. Thank you. Solve more problems.